What if I told you your brain doesn't just store memories? It secretly rewrites them every single time you recall them. That smell from childhood, that street that reminds you of someone you loved. Each time you revisit it, your brain quietly edits the past. So how does this hidden process really work? Let's take a journey inside your brain, where memories are born, molded, and sometimes transformed. It begins with encoding. Your senses flood the hippocampus, the brain's memory hub. Neurons fire together, forming stronger synaptic connections in a process called long-term potentiation. Think of it like highlighting a sentence in a book. The more often you experience or rehearse it, the brighter that highlight becomes, making it easier to find later. But the hippocampus doesn't keep the memory forever. That's where engram cells come in, the secret code keepers of memory. When you live through an important moment, certain neurons in the hippocampus are tagged, and together they form an engram, the physical trace of that memory. Over time, these traces migrate into the cortex, where they can live for years. And here's where science gets even stranger. In 2025, researchers using 3D electron microscopy found that these engram neurons don't just save memories. They actually rewire their own connections, building multi-synaptic circuits that make memories more flexible and resilient. In other words, the memory itself evolves. But memories don't just form when you're awake. At night, while you sleep, the hippocampus replays recent experiences in rapid bursts called sharp wave ripples. It's like your brain's private rehearsal, practicing the dance of yesterday so it flows smoother tomorrow. Yet, despite all this complexity, your memories aren't fixed. Scientists discovered something called representational drift. Even in stable long-term memories, the neurons involved slowly change. That means the memory of your first kiss, your favorite song, or even a painful mistake isn't identical to the way it was originally stored. Your brain is constantly refreshing it, reshaping it, almost like repainting a picture over time. And it's not just neurons doing the work. Recent breakthroughs revealed that astrocytes, star-shaped glial cells once thought to be mere support, actively help encode and store memories. Imagine discovering that the backstage crew of a theater was secretly part of the main performance all along. Now here comes the twist. When you recall a memory, your brain doesn't simply press play. It switches into reconsolidation mode, edit mode. Every recall is an opportunity for change. It can strengthen a memory, update it, or even distort it. Think of your memories not as a printed book, but as a Google Doc. Each time you open it, edits are made. The document looks familiar, but it may not be exactly the same as before. So the mystery lingers. If every memory is constantly drifting, edited, and reshaped, then how much of your past is truly real? That's the question I'll leave you with. And if your mind just took a journey tonight, hit subscribe, tap like, and tell me in the comments, what's one memory you're not even sure is real anymore? Because next time, we're diving deeper into how trauma can completely rewrite the script of memory and what that means for healing.